Thank you for coming today. My name is Akihiro Nishikawa, but too long, so please call me just Aki, aka Aki. Uh, in this session, I'll talk about several options to improve startup time of Java applications. And I'm working for Microsoft as a cloud solution architect, as you heard. And my expertise and my favorites are JVM, GraalVM, and as I working for Microsoft, so Azure. And moreover, I'm not an Office 365 expert, so I can't lecture how to use Microsoft 365 better. So if possible, I'd like to ask you to have questions about Azure or Java related technologies. And today's talk about today's session agenda is first, startup time is why startup time is so important in current technologies, current Java world. And second, startup sequence of Java applications. And after that, based on this, I'd like to explore currently available options and future options with you. Yes. And before starting the session, I'd like to share some information about the survey results, intermittent results of JCConf Taiwan. And my favorite topic is which JDK version are you using now? It's maybe still 8, but older version is so maybe you are some of guys are implementing for work, and 23 or later is not available. No one uses 23 or above, but gradually the number of users will be increasing. And another option, which framework are you using mainly, is lots of people using Spring Boot. This is the same tendency in Europe and Japan. Europe, in case of Europe, how many you guys are you using main framework mainly? The room capacity is 50, but the 49 of 50 is raise their hands, Spring Boot. Caucus, only one people. So I suppose you have had the several survey results, and you know the survey results. The Spring Boot is the most popular in the world. Yes, and the same question I asked the same question in Japan. And this is only JDK version. 6 or earlier is still maybe developing this version for work. And 23 or later, maybe an early build version is using. So they are now, but main usage is LTS, long-term support, 11, 17, and 21. Now, let me start the main topic of this session. I'd like to ask you a question about what do you think of the world performance? Startup time is one aspect of performance, but there are many other aspects and indicators of performance. For example, throughput, latency, size, memory size, storage size, memory footprint, and CPU usage. So we will focus on startup time. Okay, startup time. And in the serverless and containers era, now, from maybe 5 years ago from now, from 5 years ago and now, short-lived applications are favored over resident ones. I didn't call I don't want to call old-fashioned, but the typical application server like Java EE, Jakarta EE applications server is hosts the resident applications, but now the Docker containerized applications is most popular. So short-lived application is much favored. So poor cold start performance is not favored around the world. Now, so Java community and Java development team is now working harder actively to solve this difficulty. So, but to get on the same page, I'd like to share some boot sequence of Java applications. As you may know, as you are an expert of, you are all members, all you guys are experts of Java applications and Java boot sequence. So let me confirm the boot sequence to get on the same page. Java application startup process can be broken down into 3 phases: JVM startup, and application startup, and application warm-up. So the JVM startup is very fast, and application startup is a little bit fast, but slower than JVM startup. And after that, application warm-up it take a long time to mature to achieve the to reach the mature level. So the life cycle image is at this point, this figure, the VM init and application init and application warm-up, active warm-up is the 3 phases. The last page is below described, like JVM startup, application startup, and application warm-up is VM init and application init active. And warm-up phase is quite a take a long time, so we have to improve the startup time and to work to make Java applications work good with good performance. So we have to. Okay, just a moment. We have to shorten this phase. And tiered compilation. You guys know, all you guys know about the tiered compilation. The tiered compilation Java application and JIT compiler has JDK has mainly hotspot has 2 JIT compilers. C1 is as known as client compiler, and C2 is server compiler. From JDK 23, Oracle JDK has equipped other compiler, GraalJIT compiler, but this is not this is a kind category of C2. And C1 characteristics of each JIT compiler is C1 is short time for compilation, but not so highly optimized and not so better throughput. On the contrary, C2, in case of C2, longer time for compilation, but highly optimized and better throughput are provided. So we would like to reduce the startup time to reach the C2 phase, but C2 has to use the C2. iteration, much more iteration is required. So how to do how to reduce the compilation time and reduce the startup time is important. Yes. And the compilation level, the C1 and C2 and the interpreter, and then the C1 phase has three categories, 1, 2, 3, and totally 5 levels of compilation. C1 is C1 of one of C1 is C1 full optimization, no profiling, no profiling, and C2 and C1 no 2 and 3. So when normal case when started the Java applications interpreter phase, and after that C1 3 of C1, and after that C2. But C2 or C2 phase or C1 or 3 of C1 phase is full capacity and can't work it. Delay due to C2 capacity. Second phase, and not fully optimized, not currently C2, but the application is not used anymore, so fall back to the C1. So now optimize. Now main topic. Let me show you the main topic of this session: options to improve startup time. We have here is the overview of each options and the concept. In fact, we have several options to improve startup time, but due to the limitation of session length, 45 minutes, so I'd like to share some information covered some information about the 6 topics: custom JRE with JLink and CDS archive. As you know, CDS was introduced in JDK 9 and improved JDK 11, 12, 13, and C1 only. If you have super short live applications, C1 is the main option. And native image, as you know, GraalVM image, native image, and Grew. Crack is mainly developed in and worked by Azure systems. As you may know, you might have the name of Simon Ritter. He works in Azure systems. And last one in Leiden. Leiden is a newly introduced project and actively working on our development team. And at this time, I'd like to ask you to the question: which is the fourth fastest, not fast, fourth fastest of all listed options below? Normal jar executable jar file, extracted executable jar file, and JLink, CDS, or C1 option, and native image, Crack, and Leiden. Just a moment. Okay. Oh, JLink, extracted jar, C1 compiler only, yes. Okay, yeah. Thank you so much. Oh, Crack. Oh. And this survey is available in this session. So if you have change your answer, please feel free to change the answer in this session. Thank you. Okay. Oh, crack. Extract jar. Yeah. Good. Sounds nice. Yeah. Now the benchmark benchmark environment. I'd like to show the benchmark result environment and the core two cores and 4 gigabytes Docker images are created. And JDK version is 21.0.4, and this is G1, not serial. And the max heap is 75% allocations. And application framework is not popular in this session, but I like to use the I use the Micronaut 4.6.2. This is because my favorite framework, but also and this is very simple and quite understandable, understand easily as the results of benchmark. And another option is using the application, but this is not. This doesn't work. So this doesn't affect benchmark. So please ignore this option. And measurement style is 1,000 times run each application, and average and percentile are measured. And so the command is like this. And so you have a question. You are wondering if wait, does just extracting the executable jar file improve startup time? Not only with executable jar file. Executable jar file takes longer time than extracting executable jar file. Yes. This case, this applies to Spring Boot and Quarkus, any other framework. So now share the information, share the benchmark results. More than 5% improved in case of extracted jar. This is a base result and a base information benchmark. So I'd like to ask you to see the reduction. How much reductions? How much reduce the performance? Reduce the startup time. Now extracted jar achieves a 5% gain, more than 5% gains of gain to against normal executable jar file. Yes. Now, so we'd like to improve class loading for the first option is class loading improvement. In case custom GRE with JLink or CDS using CDS archive to load faster. So JDK, in case of custom GRE, JDEPs and JLink are used to reduce the loading size of loading class files. So now result is JLink is average data result is 94% against base jar. So 5% gain. But this performance is poorer than executable jar. So JLink, but because JLink reduces the JRE's class file, not application loading, not reduce time to load application classes. So this is a reasonable result. Yes. And you have, as you may know, JDK 20 from JDK 22, JDK crypt.ec is included in Java base. So if you create the custom JRE to contact with to speak over TLS, to speak other websites over TLS, you don't have to another modules explicitly. Yes. And next, CDS. CDS is 3 phases, improved 3 phases. JDK 10, 12, and 13. And each are called app CDS, default CDS, and dynamic CDS. So this is a command line examples of to create each CDS. But this is an example for explanation purpose. Yes, and the result is quite faster. 43, so less than half time. Quite faster. Quite faster than CDS or JLink or executable jar. This is because CDS is optimized for jar files, not class files, jar files. So if you have if you have CDS, if you create the CDS class data archive, shared archive based on class files, a little bit slower than original CDS. For example, this is a dynamic CDS and static CDS combined. A little bit faster, 42.55%. So a little bit faster, but this is not the similar great gap between them. CDS, in case of CDS, extracted jar based CDS, performance is quite slower than jar based CDS. So this is the similar performance to JLink or executable jar. So if you would like to use CDS from now on, you should. I recommend you to use CDS, jar file based CDS. And next option is C1 only. JMS, with just C1, there is no profiling overheads. So could we get better performance than with profiling enabled? So let me share benchmark results of C1. 84% based on against the base jar file results. So class file based CDS performance is similar to this result. So indeed, super short-lived applications is is better for C1 only is better for super short-lived applications, but if I'd like to ask you to use CDS to gain a better performance than C1 only. But C1 only option is recommended from AWS Lambda, customized Java runtime startup behavior for Lambda functions. In this document, they recommend us to use C1 only options, but it depends upon your use cases. So you can follow this document, and you can in that case, if you are if the option if the condition is not doesn't meet the you can't use the CDS file on your environment. It's okay. You use C1, but I'd like to ask you to use CDS, Java-based CDS files, CDS to improve performance with normal configuration. Yes. Now next, the JIT compilation offloading. It takes a long time to complete the compilation by JIT compiler. So if we can offload JIT compilation to another, it reduces, I suppose, the startup time will be improved drastically. In this case, ahead of time compilation is on the stage, like GraalVM native image, or OpenJ9 or OpenJDK project Raiden has also equipped the ahead of time compilation. GraalVM native image. I don't show the details of GraalVM native image, but you can create the native image easily with native image options, or Maven or Gradle plugin, and result is quite fast. 0.91%. So 100 times faster. Yeah. You know? Okay. So quite faster, but as you may know, the GraalVM native image is a little bit restrictions. For example, reflection a little bit difficult, or initialization is a little bit tricky. So if you can use a native image, quite good performance we can achieve. But this is not this native image doesn't work for any fields you have. So hardware and platform, CPU and operating system specific. And if you like to run your applications built with native image on Linux, you have to build Linux platform, not Windows. So a little bit tricky, and native it takes a long time, quite long time, to build a native image. For example, in my cases, Java application 10 in case of Java applications, 10 or 20 seconds, but in case of native image, 10 minutes. So a little bit longer time, but now a little bit options are introduced in GraalVM. So build time is gradually shorting, but we have to take care about the longer time compilation time when creating a build workflow like with GitHub Actions or any other platforms. Now, last 15 minutes. So shortcut, and then the shortcut to reach peak performance. We have to shortcut. If we can shortcut this phase, we can reach the peak performance level faster. So in that case, checkpoint like crack. So crack is coordinate restore at checkpoint. The application start point, you can take a snapshot at this, and when start up next time, this phase is bypassed and start from here. So quite fast. You can imagine how fast is it. But a little bit tricky restriction is found in Crack. Crack has a restriction. I marked the yellow. Resources like open files or sockets cannot. So it is required to release them when checkpoint is made. So when you take a checkpoint of applications, you have to close IO files or sockets. Close. After that, take a snapshot checkpoint, and finally restore checkpoint. Restore IO. So now crack command is like this. You can take a checkpoint with J command, and this command is called checkpoint files is created in the path specified this checkpoint file here. After that, restore the snapshot and start with the checkpoint files. This one. Now, let me see the results of crack. Quite faster, but not the same as but slower than native image. So crack is two times slower, but based on the basement of jar files, quite faster. 50 times faster. So now, in that case, we can achieve the good startup time performance, but a little bit tricky. So please be careful for this point. Project is now undergoing, and privileged operation is required. This is very tricky. So you can, if you like to use this crack technology with Docker container or containerized application platform, some containerized platform is doesn't accept the privileged operation. So please be careful when using the crack. Yes. Now This is totally. This is a result of each technique, each option listed with graph, bar chart. So now we have another option, and now we have another option, and which will be introduced near future. That is Project Raiden. This was introduced in 2022 or 2023, and now actively working actively for this with this option. The concept is shifting computation. So and the Project Raiden covers cache store, so to reduce the startup, and AOT compiled with to GTOP loading. So Project Raiden covers several options which I covered previously. Now I check the in this project if Project Raiden is used benchmark environment should be modified, because Raiden applied JDK is not generally available. So Raiden early access build we have to use Raiden early access build. This is based on JDK 24. So, and you can use JDK 24 early build access from OpenJDK.org. And application framework is 4.61, sorry, 40. This is a typo. 4.6.2. That's other configuration is the same as other benchmark. In that case, and when calling the Raiden applicable application JDK, the cache data store option is specified to store the cache data store. And I talked about the CDS, class data file sharing, but the name of a CDS is changed when using Raiden. In case of Raiden, CDS stands for cache data store. But the same contents is similar to the normal CDS, but the definition is changed. So, in case of Raiden, please be careful when you explain others to see the word of CDS. Now, share the results of this benchmark. So this is a pre-main phase. So the Raiden is now pre-main phase. So this is not optimized, but as of now, quite faster than base performance when we measured with executable jar files. So one third of jar file, executable jar file performance we can gain. And Raiden, Crack, and native image, we can especially Raiden and Crack and native image. We describe the bar chart with in this screen. Indeed, the Crack and native image is too fast. So Raiden is quite slower. You can see Raiden is seems too small, too slow. But base against the base image, we can gain a much more performance than base model. So now I ask you the poll. I took the poll in the middle of this session. So C1 only is quite large the majority, but just a moment. Oh, CDS. Oh, sorry. Just a moment ね。よし。Okay. こっちしてみよう。いいよ。Maybe Crack and Raiden is a little bit smaller, so a little bit different results you imagine, but now currently the fourth result is the fastest option is CDS. Yeah. Okay. So takeaways. We have several options. There are several options in front of us, and currently we have and several options have already been available, like CDS, C1, or any other. Needless to say, Graph native image, Graph VM native image, but several options like Crack and Raiden is now approaching, and so the development is now ongoing. So please note that we should choose the most suitable technique based on the characteristics and requirements of applications. Yes, thank you so much.